Hello children, I am pleased to welcome you all to this maths class, and I believe all my kids are like this fire and ferocious and aggressive in doing maths. I am really happy children, and you are all doing well in your test, and let's keep up this aggressive mood till we proceed in this digital mode of learning. Okay, today is a puzzle for you. I believe many of you would have come across these triangles, and now again I want you all people to count the number of triangles in this triangle. Start counting. Hope you are all counting. How you are counting? Start from the small one, 1, then this 2, 3, 4, then this one small 5, then 6, then 7, 8, here 9, 10, 11, 12. So far we have counted 12. Now I am going to club two triangles together. So this big one, this one, 13, then bigger one, 14, then 15, 16, over, then clubbing these two triangles, 17, 18, 19, 20. Okay, then 21, 3 together, 22, 23, 24. How many triangles are there? Yes, there are 24 triangles. Okay, children. And now let's have a recap of what we learned in previous class. We started with median of a triangle, and it is the line segment that joins the vertex of a triangle to the midpoint of the opposite. And what is the meeting point of all these medians? We will have 3 medians in a triangle, and all these 3 medians meet at a point called centroid. Centroid is defined as the point of intersection of all the 3 medians. You may be asked to define centroid, define median. At that time you should mention these sentences. Okay. Now another one more thing we learned. What are those? Yes, the perpendicular line segment. We need not locate the midpoint now. It is enough if the line is perpendicular, drawn from the one vertex to its opposite side, is called altitude, and the meeting point of this altitude is orthocenter. While defining, be careful. Orthocenter of a triangle is the intersection point or point of intersection. Both means the same. Of 3 altitudes drawn from the vertices to the opposite side. Okay, children, and let us have the diagrams now. See here, for centroid, we have to locate the midpoint here. Here one midpoint. Midpoint in the sense these two should be equal. BD and DC should be equal. This is 7 centimeter means here 3.5, here 3.5. Such a way you have to locate the midpoint. If this is a 12 centimeter, AC is 12 centimeter means at 6 centimeter you have to locate this point. Is it clear? If this is 10 centimeter, at 5 centimeter you will locate this point F. Then you will draw the line segment joining F and C, A and D, and B and E. All these 3 medians meet at a point called centroid. Now here this is orthocenter. Here I am not locating any point D, E, F. I am not locating it first. First I will draw the perpendicular line. How to draw perpendicular line? Using a set square and scale. And you have to draw that perpendicular line. Okay. All these perpendicular lines meet at a point called orthocenter. Then we have perpendicular bisector. This is just a perpendicular line, and it is not necessary that D, E, F should be the midpoint of the sides. But here in perpendicular bisector, this M point should be the midpoint. Also, this PM line should be perpendicular. I am combining these two rules together. midpoint as well as perpendicular. That's why it is called as perpendicular bisector. This perpendicular bisector again meets at a point called circumcenter. And then we draw angular bisector. All these three angular bisector meet at a point called incenter. Okay. Now as a summarization, I have told you to have all these four things in your mind. Medians meet at centroid, altitudes meet at orthocenter, perpendicular bisector meets at circumcenter, angular bisector meets at incenter. Now today we are going to talk about exterior angle. Do you have any idea about exterior angle? If we are going to have some exterior, definitely we will have interior angles also, isn't it? Something inside is interior, something outside is exterior. Yes. Here, if I extend the side of a triangle, see this is a triangle, and if I extend that one line segment, I get an exterior angle. So how many exterior angles are possible? How many lines can be extended likewise? Very good. For time, you will say we will have 3 exterior angles. See, if I extend this line, I get one angle. If I extend this line, I get one angle. If I extend this line, I get one exterior angle. Is that all? Or is it possible to have more than these 3 exterior angles? Is it possible to have more than these 3 exterior angles? Think. See here. Here I have extended the line this way. But here I have extended the line BC, this small base, no, this BC. This line I have extended towards right here. But in this diagram, I have extended towards left. So, how many exterior angles are possible for a triangle? Hope you all would have guessed. If we have 3 in clockwise, we will have another 3 in anti-clockwise. Totally, we will have 6 exterior angles. See here. Here I have extended everything. Here this side, right side. Again here, this side. All in anti-clockwise direction. Sorry, clockwise direction. Okay. Here, anti-clockwise direction. This see, in set 1, here I have red color. Opposite to that, if I extend this line in opposite direction, this direction, I have another angle. Are you able to identify how many exterior angles do a triangle have? This is the same triangle. Here also the same triangle. Both are same triangles. Only thing is the line extension is different. Here it is extended towards right. Here the line is extended towards left. If I extend towards right, we have one exterior angle. If we extend towards left, we have another exterior angle. So totally, how many exterior angles we have? See here, I have extended these line segment now, this A, B, C. See, if this point is A, no, at this point, I have extended as well as this side. Okay, let me locate B and also C. Then it will be clear. See this line segment A, B. This line segment is extended beyond here also in the left and also in the right. Therefore, we get here one exterior angle and here one exterior angle. Similarly, in all the vertex, if I keep on extending, totally I get 6 exterior angle. Hope you are clear that we have 6 exterior angles. Okay, for a triangle. So, if there is exterior angle, surely we will talk about interior angles. Here I am going to specially talk about interior opposite angles. How many interior angles are there in a triangle? Inside a triangle, only 3 is there. We cannot have more than 3 angles in a triangle. But here I am specifically talking about interior opposite angles. It means for an exterior angle, we will have opposite angles. Here it is. If this is an exterior angle, if I am extending this B and C towards left, I have extended the line segment BC towards left and I have got this angle exterior angle. And I have 3 interior angles. This is also one interior angles. This is also one anterior angles and this is also an interior angle. But what is the angle opposite to this exterior angle? We have only A and B. These two are called as opposite interior angles or interior opposite angles. Okay, both the ways you can say. Is it clear, my dear children? And also note that exterior angle and one interior adjacent angle. This angle is adjacent to exterior angle. Adjacent A, D, J. Adjacent angle. These two together, if you add, you will get 180 degree because it will become a straight angle. Is it clear, my dear children? We have to note many things in this triangle. One thing, exterior angle, two opposite interior angles, and one adjacent angle to exterior angle. And these two angles together will make 180 degree. And now we are going to see the relationship between exterior angles and interior angles. Are you all ready, my dear children? Take a paper and draw a triangle. And I have made it ready for you. See here. This is a triangle. And I have extended the line towards right. And we have three angles, A, angle B and angle C. And this is the exterior angle. And we have two opposite interior angles. What are the two opposite interior angles? A and B. See here, now I am going to cut off this angle A. I have taken this angle A. And also angle B. I have taken out angle A and angle B. I have taken out angle A and angle B. Okay. Now I am placing this in exterior angle. B. This is angle A. What do you feel now? I brought both angle A and B and it exactly fixes inside that exterior angle. Isn't it? This exterior angle is equal to both the angles, the opposite angles that I have torn off now, that I have tied and keep it here. It exactly fixes here. Isn't it? So, exterior angle is equal to addition of angle A and B. Will you all agree to it? Is it clear? Okay, children. And you can do it at home now with a paper as I have done for you. Okay, now let's continue with slides. See here, this is called as exterior angle property of a triangle. What is this property called as? This property is called as exterior angle property of a triangle. It states that exterior angle, this exterior angle is equal to sum of two interior angles. They may also ask you to define exterior or state the exterior angle property of a triangle in 1 mark or 2 marks. So you should know to write the definition or statement for that property. So how will you define? No need to memorize. Understand and write. See, this exterior angle is equal to sum of two opposite interior angles. Just in your own words, you can state the property. Okay. The exterior angle of a triangle is equal to sum of two opposite interior angles. Hope it is clear, my dear children. And we will continue the application and few more derivation of these exterior angles in next video. Bye-bye.